Welcome to today's stream. And what I'm hoping to do today is to look at Java file IO APIs, specifically the old file IO libraries like buffered reader, file writer, and also look at the new ones under Java Neo package. And things like paths, the new files API, and some of the wrapper classes that were developed to make file operations in Java much more convenient. So this would just be an exploration of those features. I don't intend on doing anything beyond that. And the reason why I'm doing this is soon I'll be covering a session for the Kenya Java user group, which is a Java user group based here in Nairobi. And I'll be leading some sessions on file operations. And before that, I just thought it would be good to go back to some of those old libraries and see if there's a clear way to present that to somebody who is new to Java, and at the same time help them appreciate how much better the Neo libraries are as opposed to the old libraries, and also to appreciate what you could probably achieve by going back to those old libraries and working with them before you adopt the new ones. So in this stream, I'll spend some of it reading some JEPs, Java enhancement proposals, and just trying to trace that path. I'll also do some code samples, some live coding, to see if I remember some of the concepts as relates to file IO. So just looking at the JEP page here, I can see there's a dedicated section for networking, and IO is like a close relative to networking, so they'll have some similarities, and I'll just look at that, and then I'll see which other parts of the JEP cover aspects that might be important to what I'm doing. Let me see what's in networking. Okay, so this has the HTTP client project. Yeah, I thought this would start with sockets, but yeah, I guess the main project under networking currently within Java is HTTP client. It's the most recent thing. I think this was introduced in Java 11, and it allows you to do HTTP requests, and let's just check out some of the JEPs there. So JEP 110 delivered the HTTP client in incubation, standardized HTTP client, and 517 added HTTP 3 support to the client. It's a fairly easy to use API, but it's one of those APIs that grow with complexity depending on what you're doing with it. So if you're just doing a GET request, it might seem easier to use, but then when you are doing far more complex things like async IO, things like serialization, then it might get a bit complicated. So standardized the incubated HTTP client API introduced in JDK 9 via JEP 110. Maybe I should read JEP 110 first before I go to the other JEP. So define a new HTTP client. So this is by Brian Goetz. He's responsible for a lot of enhancements in the language, or at least he's sponsored most of the enhancement proposals. So I guess he's also responsible for this. So this is back in 2022, last updated 2022. It was introduced in 2014. That's a really long time ago. So define a new HTTP client API that implements HTTP2 and WebSockets and can replace legacy HTTP URL connection, which is the legacy API. If you do Android development, you'll notice a lot of this use of HTTP URL connection. So HTTP, the Java 11 HTTP client works more like a convenience API. The underlying networking doesn't change as much except for support for HTTP2. And I think a URL connection supported WebSockets, although I can't remember that. So libraries like Retrofit, OK HTTP, they run on HTTP URL connection, if I'm not wrong. So it's a very critical API. So the Java 11 HTTP client enhancements sort of wrote wrappers around that. The API will live under JDK incubator. The module will not resolve by default or runtime. Okay, so this covers the goals. Let me go to something more practical. So separate request and response, like the servlet and HTTP server API, asynchronous notification. So you can get async request processing, which is nice. Response error, response body received, server push for support for HTTP2, and some support for HTTPS, which is just SSL, TLS, secure transmission. Proxying, I don't know how this would be relevant for HTTP client. Maybe if the client was acting as a proxy to some other service, maybe in the context of microservice architecture, that this might be useful. Cookies, that makes sense for web applications. And auth. Authentication usually runs through headers. So if you have like an auth token, or you are old school and you're doing basic auth, you probably have that encoded token in your request header. So I get how that could be related to this. This JEP doesn't cover anything practical. So no demonstration of how this works at all. Okay. Let's see if the follow-up JEP goes into a bit more detail. So 321 was after 110. So 321 talks about the goals, changes over what was incubated in 10. Okay, redirect policy for handling 3.1. Okay. and some enhancements for WebSockets. Again, nothing practical. So I guess we have to go into the guides for it. Okay. I saw a link for the guides in one of these chips. Okay, so there's a guide here. So it talks about the HTTP client. So this is how you create the client, and then you get a request builder. You can pass in the URI to the resource that you want to hit on the destination server, and yeah, you can use send async. Okay. Let's try this in practice. So first of all, you need the client, HTTP client dot new HTTP client. So this would give you a valid HTTP client, and with the client you can initialize an authenticator. What this does. Returns an option containing the proxy selector supplied to this client. If no proxy selector was set in the client's builder, then the optional is empty. What is this proxy selector? So selects the proxy server to use, if any, when connecting to the network resource referenced by a URL. Okay. I guess this is when you have a proxy sitting between you and the server you're trying to reach, because it's a client library. Where proxies have made sense to me is in the server environment, where you have something like Nginx sitting in between you and the client. So requests come in, they hit Nginx or Apache, and then you redirect those requests to the actual backend. That could be your Tomcat engine or multiple Tomcat instances sitting on your backend, but you can have all the requests coming from one source, and then you redirect them through your Nginx. So on the client side, I don't know. It doesn't make much sense to me. I guess it's just based on my experience. I've never had a need for that. So what can you do with this builder? Okay, so I guess this is timeout. You could set a timeout for the request. Maybe duration of millis, and that could be like 100. Okay. So there's an exception here for in the case where you use a timeout. But in the first example, I don't want to use a timeout. I mean, in the first try of this. So I'm also re-exploring these APIs. When the new HTTP client API came out, I used it for a bit. But in the context of Spring Boot, but within Spring Boot, you also have a REST template, I think. And REST template essentially acts as another sort of HTTP client, REST template. So you don't really need to use HTTP client if you're in Spring Boot, Spring Framework environment. But for a time there, I used it for a while. So REST template is a synchronous client for performing HTTP requests, exposing a simple template method API over underlying HTTP client libraries. There's a lot of similarities between this and the HTTP client library, in that they are all HTTP clients or HTTP client libs, falling into the class of curl, more user-driven, something like Postman, but Postman is less programmatic. It's like you use it on a UI and stuff. So it could be different. But REST template and HTTP client are very similar. I think it might even be the case that, REST template, it might even be the case that REST template wraps HTTP client. I would not be surprised if that was the case. So this one is in the Spring Framework project, which we can actually check out and see if I'm right about it, wrapping I think Spring projects. Spring Framework, REST template. Okay, so this is the implementation. So it uses this HTTP message converters. Okay. What are these HTTP headers from? Let's see. Okay. Okay, synchronous client to perform HTTP client request, exposing a simple blah blah blah. So I guess this is independent from HTTP client. So it's not just a wrapper, because message converters are a Spring Framework concept. They essentially make it easy for Spring Framework and Spring Boot to automatically handle serialization and deserialization of data coming into and leaving your server. So I get a request body that contains JSON or XML or plain text. Message converters are able to decide how that will be converted into your own internal objects. This also helps with SRPs. Is that the right abbreviation? Server rendered pages. So if you are working with something like ThemeLeaf, you can configure message converters to handle mapping or binding values that you render to ThemeLeaf from your own backend. I was expecting to see references to HTTP client here, but that doesn't seem to be the case. So I guess this is independent from HTTP client. or at least the JDK's implementation of HTTP client. The underlying implementation could have some similarities, but they're different. Of course, the actual networking is sockets, so in a way they're kind of wrappers of the same functionality, just independent of each other. Okay, so so this creates the client, and then we can create the request. So we can have the request, and I guess that's a different separate class request. That gives us a builder, and we can use that builder to build the request essentially. So this builder also will allow us to build the client. If you want to set up the proxy, the indicators, timeout, I assume this termination is a way for you to configure timeout. Blocks until all operations have completed execution after shutdown request or the duration lapses, or the current thread is interrupted, whichever happens first. Okay. Yeah. Let me see if I can get a request done. So this would allow you to specify headers. So if you had auth, you'd probably have, oh, there's some preset headers. Okay. Accept encoding, maybe UTF-8. Okay, and we could set up the, okay, so I'm seeing HTTP methods here. So I guess this allows you to just specify that you're doing a get. The headers method seems to allow you to set up multiple headers as key value pairs. So you could chain them if you have multiple headers, I think. So here we could do, oh wait, isn't this, yeah, that's variables. I should be able to chain them. So if I have accept cassette, accept application JSON, I think you could chain them like that. Again, I'm just exploring these APIs. This is not meant to be like a tutorial or anything. Just going back to it. It's one of those APIs that, because of the nature or of the tools that personally I use day to day, I don't interact with as regularly as I would wish. Because when I'm doing HTTP client, if it's server side, I'll use Spring REST template. On mobile, I'll use retrofit, or on iOS, there's some networking tools for that. So it's a rare occurrence to use HTTP client, but it's also good to know how to like work with it. Okay, so I guess this is where we specify the URI, and oh, there's URI.create. And here you could say we are hitting www.google.com. And yeah, oh yeah, so you specify the timeout separately. So I could say this will time out in duration of I think I have of seconds. maybe 4 seconds. And yeah, you can end it with the build. So so these HTTP methods allow you to specify which method you're using for the request, because this request can be any, it can be a post request, it can be a put. So in this case, it's a get. And let me just make sure that's what that method does. So it says the request method for this builder to get, this is the default return. Yeah. So it just specifies which HTTP method you'll be using for the request. And so that gives us a client and a request. So how do we combine them? So once you have a client and a request, you can call send, async. You could also call send and pass in the request. And there's this concept of body handlers. I guess body handlers is how you define how the method you're going to use to handle the response from the server. Because the server could be responding with JSON and you want to convert that JSON into a Java object so that you can start using it. You might respond with HTML and you want to render that HTML or embed it somewhere or just plain text. So I think body handlers is what allows you to define how you're going to interact with the contents that come come from the server. So let's try this out. So client.send. So I won't use send async, just use send, and then we specify the request, and then we specify this body handler thing. So let me look at the docs. Let's see what this does. So handler for response bodies, this class body handlers provides implementations of many common body handlers. The body handler interface allows inspection of the response code and headers before the actual response body is received. Okay, so you can check the headers and status codes so that if you get like a 400, you can handle it before you attempt to extract the response body. So it is also responsible for creating the response body subscriber. The body subscriber consumes the actual response body bytes and typically converts them into a higher level Java type. Okay, so once you specify the type, I guess you get automatic conversion. So you don't have to bring in Jackson or write your own serialization, deserialization logic. A body handler is a function that takes a response info object and which returns a body subscriber. So what this body subscriber is. I wish the JEP was a bit more detailed because there's a lot of terminology here that should be specified. I'm just surprised that the JEP didn't go as far as specifying those concepts like body handler. Okay. So a predefined implementation of body publisher, body handler, and body subscriber created through static factory methods have been moved out to separate non-instantiable utility factory classes. Maybe I can find it in the original. 110, body handler, no reference. So the JEPs don't talk about these concepts, at least not exhaustively. It should at least start by a definition of what a body handler is, which is strange that is not there. So I guess the only definition we have is from the Java doc. But the main idea is once you get the response from the server as JSON or HTML or plain text. The body handlers allows you to deal with that response body. In the case where there is no response body and you just have a status code like 301, 400, 500, we're able to get that status code and act accordingly based on what the server sends back. That is the overarching idea. So the details is what body handlers actually is and what this body subscriber is, which we can dig into. Okay, there's some code sample here. I think this just forms the request. You specify the URI and then you build. Center sync body handlers dot off file. So I guess they're using static methods to determine the types of body handlers. So if I extracted this to like a separate variable, I could do HTTP response dot body handler, and here we need to specify. I guess this allows us to specify the object that will be mapping to the request body. But I can confirm that. Let me see. So type parameter T, the response body type, yes. So this allows us to specify the type. So if we were getting a complex object from the server, like if this was a request to fetch an account, so you can have an account like so, and this account has a name and it has an ID. So you can specify here. So you can specify here that I'm expecting an account. And I guess that would allow us to access the other methods. Okay, maybe you can do it here. What? This is strange. Okay, HTTP response body handler. But I just saw them being referenced from a static context. Yeah, body handler. Where is it? Okay, body handler, response info. Where is response info from? Okay, so when we send the request, we pass the request to the client and the body handler, but we create the body handler from response info. Okay, where do we get response info? So it's a lambda. Okay, so it's a lambda. So in this lambda, we are referencing this. Oh yeah, okay. So it's a lambda that accepts variable response info. And then we use that response info to get the status code. And if the status code is 200, we call body subscribers and extract the actual response body. If not, if the response status code is not 200, and I guess here you can change the condition. You can use a different condition like 201, whichever condition that you want to use here. And since it's a lambda, you could have custom logic in here. Actually, let's try to replicate that. So it's a body handler, then the path. So the way we do that is body handler, the path, here, instead of creating an instance, we have response info, and in that response info, so that lambda will generate the actual body handler, which we will end up using here. Of course, there is an exception class, interrupted exception. Could get sneaky and just throw an exception there. That should cover it. So we can use this response info to check the status code, and we could say if status code is HTTP status. Okay, so it's an actual integer. It expects the actual int. I just wish there was like a wrapper class for it. Maybe something nested to HTTP response. No. Okay, I've gotten too used to Spring Boot HTTP status because you could do okay there. Map it to, okay, so let's say this is 200, and if that is the case, then we can try and extract the actual response body, which is not wrapped in response info. So where do I get the response body? Okay. Get back to that sample. Okay, so so this is where we refer to body subscribers, and so body subscribers dot of, so of byte array, of file, of lines, of publisher, of string. So if I'm getting JSON or a HTML document from the server, I think this would suffice. And the character set here would be UTF-8. I need to specify differently. In fact, I could just do default. Yeah. So I guess we can return the subscriber. Otherwise, so in this case, we would probably have gotten a different status code. So this is the response body. So this is the body, and we can do whatever we want with the body at this point. So let me just print it. Response body. And if things fail, this would be our failure code. So we could throw an assertion here. It could say assertion error, HTTP request failed. So apparently we are supposed to return something from this lambda. So let me just see what could be. So okay, so we are supposed to return a body subscriber. So it's a lambda that accepts a response info and returns back a body subscriber. So we do return body. Isn't this a body subscriber? Yeah. Why can't I return it? Body subscriber cannot be converted. Okay, so I specified that it would be a path. So this is string. If not, I'm hoping there's like static body subscribers. And okay, of string. So essentially I'm doing the same thing I'm doing here, because I thought this is where I would handle the response from the server, but that's not the case. If you return this here, I guess it would, yeah. Unreachable statement. Oh yeah, because of this session error. So this would solve it. You still do the return type here. So we just need to end that. Yeah, so I'm essentially repeating myself, but then I don't see why I would need to check the status code if I'm just going to return the same thing. Maybe it's because I still don't understand what body subscribers actually do. So implementations of body subscriber that implement various useful subscribers. Hey Alex, how are you doing? Checking out the JEP for I'm checking out this JEP for HTTP client, and trying to remember some of the concepts that were introduced with that API. So implementation of subscriber that implements various useful subscribers, such as converting the response body bytes into a string or streaming the bytes to a file. Okay, then why would we need to return a different subscriber based on the status code? Or why do we need to specify the subscriber at all? Yeah, that doesn't make sense to me yet. So there's some examples here. Send, specify the response. So you have the lambda that receives the response info. So this response info must be what HTTP client translates the response from the server as. The response from the server, of course, has the status code and the response body, so they'll be wrapped inside this response info. Or at least I think they're wrapped inside the response info. And yeah, so you use that to form a body subscriber. So you don't even need to have the status code check. It's probably not very relevant, because you just need to return the subscriber, which allows you to specify what kind of data you expect to get from the server. So in real sense, what we would need to do here is just do body subscribers.of string, and we specify the character set. Drop this down a bit so it's easy. So character set.default character set, and that should do it. We might do something with the response info, or we might decide not to do anything with it, and then we just pass that to the body handler. Now, what does send do? So send accepts a HTTP request and the body handler, and the docs say that it does what with it. So sends the given request using this client, blocking if necessary to get the response. The returned response contains the response status, headers, and body as handled by a given response body handler. Okay. If the operation is interrupted, the default client implementation attempts to cancel the exchange, and it will throw interrupted exception, and no guarantee is made as to exactly when the cancellation request may be taken into account. In particular, the request might still get sent to the server as its processing might already have started asynchronously in another thread, and the underlying resources may only be released asynchronously. So it's a typical IO. Once you initiate it, it's in the system, and cancellations are not guaranteed. I think the only thing I'm interested in knowing here is okay, so the return type is HTTP response. Let me see what the docs say about that. So returns the response, and it will throw a bunch of exceptions if anything goes wrong, including IO exception. So if an IO error occurs when they're sending or receiving, or the client has shut down, interrupted exception if the operation is interrupted, and illegal argument if the request argument is not a request that could have been validly billed as specified by the request builder. Okay. So illegal argument if you used the wrong configuration for the HTTP request. Okay, so what we expect here is the actual response. So once we have the actual response, yeah, I guess we could do processing with the actual response. So we get the response body, response body. So the fact that we're getting the response body when we call send just makes it a bit additionally foggy for me in terms of knowing what the purpose of this body handler is, because I thought it would allow you to specify how the response would be handled in advance. You could say once the response is received, do XYZ before you actually call send. But the fact that the send function already gives you the response, and in the response you can actually access the body, you can access I guess you can access the headers, you can access status code. I'll need to take some time to understand what body handler does, because it's clearly not what I thought it does. Oh, thanks, Alex, and thanks for joining the stream. Reading is kind of boring for most people. That's why I thought I'd do a stream on me just reading. Yeah, so JFE and JB are still on. Java by example, Java for everyone. Except that somebody else is taking over Java for everyone for the next maybe 2 sessions or the next couple of weeks, depending on how they structure their bit of the curriculum. But JB is still on Friday, which I'm excited to do again this Friday. Yeah. So I'm stuck on the right approach to Spring Boot. Could you please show me the best approach? No, you're not distracting. So I'm just also just chilling here and reading. Spring Boot, the best approach. So if you're just beginning, I think the best place to start would be, I always advocate for learning the bones of whichever framework or tool you're using. So they encourage you to start with the bare bones. Don't be distracted by the glitter of going directly to work with like Spring Data JPA or working with WebMVC or some of that stuff. The best place to start would be with the IOC container. IOC, yeah. IOC. The best place to start Spring or Spring Framework would be this IOC thing, inversion of control, IOC container. So if you can read this, if you can take time and just go through this small or not very small piece of documentation on IOC, this would be the best place to start learning Spring, because it will teach you the foundations of how Spring and Spring Boot functions and what makes them different from other backend frameworks. I'm tempted to say Jakarta EE, but Jakarta EE also has some dependency injection library that's specific for Jakarta EE. But if you are doing, if you want to learn Spring Boot or Spring Framework, this would be the best place to start. And once you understand IOC, you understand the bean factory, you understand application context, you understand what a bean is, and how you configure an application context, and you understand some of the stereotype annotations, like at bean, at service, at all that, and you understand something called component scanning, which is how Java discovers the beans that are registered in your application, which is basically the specialized classes that form either your persistence layer, your service layer, or your controllers. If you understand how Spring discovers those things and does auto configuration for you based on the classes, on the annotations that you use, then you'll be ready to now look at the actual specialized components of Spring Framework and Spring Boot, which is Spring Data JPA and Spring MVC. But this is the best place to start. This is where I would recommend you go. Let me see if I can share the link. But it's just on Spring Docs. Go spend some time there. There's a guy on YouTube, Java Brains. He basically he did a series on IOC. I think it's very old, maybe 2010 or something, and he covered this bit very well. So if you can also find that, that can really help to have a foundation, not just to kind of cram some steps and be able to achieve some tasks within Spring Boot, but actually being able to know what is happening underneath. So the documentation is fairly old school. It's not what you'd see in the modern Spring Boot documentation. But a lot of people forget that Spring Boot is just a wrapper for Spring Framework. So it's good to understand Spring Framework. Yeah. So yeah, read there. That would be the place I would advocate starting at before you go to do other things in Spring. Okay. So I can see that we're able to get almost everything from this response object. So we can also get the status code. So the two most important things that you can get from a HTTP request to a server is the status code, whether you are authorized or not. If you are not authorized, you'd probably get like a 401 or something like that, or 301 in some cases. If you're being redirected, of course, 301. If the object you created was successful, it was created successfully with 201, or just 200 telling you that everything is okay. The second thing that is important is the response body. So looks like you can get both those things. Of course, response headers as well, if you're doing something specific. So I'm wondering what the purpose of this body handler is, if I'm able to still get the things that I care about, which is the response body and the status code, which I can try to print here. So this is the body. Let me use text blocks for this. So we have the body, and we have the status code. Formatted response body and status code. So this should already work. I don't know if I can use character set here. Default, so we get a string representation of that here. Okay, yeah, that's better. Since I'm hitting www.google, I'll probably not get JSON. So maybe I can leave out the specification for the media type that we expect to receive. And yeah, let's see what happens with this. Okay, so that doesn't work. You arrive with undefined scheme. Okay. HTTPS. Okay, so that works. We get back the default Google page. Okay, so it's not too complicated. I don't know if there's a public API that we can use without a key. Public API. Okay, so there's weather stack. Okay, let's try this. Okay, it's free, but do I need an API key? Okay, since there's pricing information here, I definitely need an API key, or I'm likely to require an API key to use this. Let's see, pricing documentation. Okay, weather stack API documentation. So there's a /current to retrieve real-time weather for specified location, free and above. Okay. Okay, that's all good. But okay, yeah. So I need an API key. Or do I? I thought that would be the first thing they specify. Okay, yeah. So yeah, let's. Okay. So they want all my biometric information before I get an API key. Let me see if I can set this up privately. Move to a new window. Let me sell myself for a second so that I get this API key, and maybe you can use it for testing. So I'll just give them my name, my email. And I need a password, billing address, postal code. Oh my goodness. Country. It's a really long form. Well, let me see if I can get the information set up so that I can use like a live API for testing this. Nice. Where is the API key? Okay, so I have an API key, which I'll do my best to hide since I'm doing this live. Okay, I wish this didn't require an API key. Working with this live will be tricky. Because even if I'm like setting it up to be hidden somewhere in my local environment, I'll still probably end up showing that in my code. And so I wanted this to be as simple as possible. I don't know if there's are there public APIs that don't require an API key? I just want some sample JSON, some sample behavior that I can use to test out HTTP client. But this seems to be, although it's just the way that they seem to have taken this whole thing very seriously. So view real-time status data for popular services. Okay. If I don't need an API key, documentation. Okay, this is not okay. I don't think this is going to work out, so I'll just explore the API with without trying to do actual tests with the actual endpoints that have JSON. I could build out a simple hello world endpoint and try calling it from HTTP client. While it's running locally on a separate port. I guess that could work. But I'll spend time setting up Spring Boot and writing the endpoints, and I would be spending time exploring HTTP client. Okay, at least I've seen the basics of how this works. So this is how you form the HTTP client. And I didn't even call build here. So that's okay. So it's not a regular build. Okay. So this is not a build. This actually gives you the HTTP client. So anyway, this is how this whole thing works. Let me see if I can unravel what this body handler is. Okay, so the HTTP client, to send a request, first create a HTTP client from its builder. The builder can be used to configure per client state, like preferred protocol version, whether to follow redirects, proxy, or an authenticator. Okay. Client, HTTP client. Also, you can specify the HTTP version you're using here. Okay, so okay, you can create a HTTP client directly, or you can get a builder, and here you can specify a few things like the HTTP version. So if this was 2, you can also specify a cookie handler. Okay, so you can specify an executor if you want to do this asynchronously or concurrently. Proxy, SSL parameters, SSL context. Okay, there's a few things you can specify there. Maybe version is the most important. And follow redirects. Yeah, but this is rare. For most regular clients, you'd probably, maybe web client. If you're doing a web client, the browser, you'd probably want that. Then get the final path and present that content to the user. So if there's a proxy nearby, you can specify the proxy and the port it's running on. So once we do that, we have a valid HTTP client. Then HTTP request is created from its builder. The request builder can be used to set the request URI, the request method, so just like we did with the get here. The request body, if any. Interesting. We were not able to do like a request that has a request body. But let's see how it's done. Although that would require having an actual endpoint that we can submit something to. And I can't think of one at the top of my head right now. So I guess that's specified on the request. Let me have a request to HTTP request. New builder. So it looks like you can specify the URI right away. So if this was HTTPS www.company.com/form, we are submitting some form. You could just specify that in line, and then this would be post. Then okay, so now you interact with the body publisher. I guess that's another idea that we don't look at. So this was body handler, this body publisher. Let's see what this is about. So body publisher converts a high-level Java object into a flow of byte buffers suitable for sending as a request body. So it will take your Java object and serialize it. The body publisher interface extends flow publisher byte buffer, which means that a body publisher acts as a publisher of byte buffers. Okay, how to use. So each outgoing request results in one HTTP client subscriber subscribing to the body publisher in order to provide the sequence of byte buffers containing the request body. Okay. A body publisher that reports a content length of 0 may not be subscribed to by any HTTP client as it has effectively no data to publish. content length. Okay. So I guess it will automatically calculate the content length based on the size of your payload. So this is not a field that you should be specifying separately. So how do we get a body publisher? So body pub HTTP request body publisher. Okay, we'll get it from body publishers. So from publisher or file or string. Okay, so you could specify that, and this could be your payload, and the payload is some JSON here, which the JSON could be just an account. Could have an account as opposed to a new account. Then this account belongs to Jenny. Jenny Richard. And the ID is that. And we can convert this into the actual JSON payload with Jackson. We'll bring a new object upper. Printer. Okay, I need to add Jackson to class path. So let me see if I can get a copy of Jackson. Maven repository. Jackson. Data bind. I think this will do. And I'll add it to my dependencies here. Oh, I don't need to. Just add it directly. And let IntelliJ try to resolve it, or we could also do a clean install. Okay, so that fails because we have some errors in the code. So we can do that again when clean install. Yeah, it's already here. So we import object mapper from Jackson and get a pretty printer and value string and pass in the account. So this will allow us to convert the account into JSON, and we can pass that JSON string as part of our request body, and this will be our body publisher. Okay. We can specify other things. So we've already specified the request URI, and we've specified the HTTP method. We can specify timeout. This is using duration from java.time. This is such a convenient API. Minutes, okay, of seconds maybe. Makes more sense. And we can call build on it to get the actual request. I guess we can reuse the client, so we don't need to create a new client for this. So you could do client.send, pass in the request, and then we need to pass in the thing that I still don't understand, which is this body publisher, body handler. Yeah. I don't get why this is important, or what's the use for it. Because on the client, on the HTTP request, you can specify the details of your client. You can specify the request you write, the HTTP method. You can specify timeout. You can specify encoding. You can specify everything. And then on the response, you get everything you need. You get the status code, you get the response body. If you're getting any headers from the server, you're able to get them there. So I don't understand what the deal is with the body handler. Maybe I will one day. Also, the documentation on it is very limited, so it's difficult to understand what it's about. Yeah. What's the deal with this? A handler for response body. So would this be for converting the JSON into Java objects? But also, why would I need it? Wouldn't I just get the response body from the response like we did here? And if part of that response body is JSON, then I could use Jackson object mapper to convert that JSON string into the Java object. Or is the purpose of it that we would do that conversion in the Lambda, so that passing that Lambda as automatic functionality on the client itself? Doesn't make a lot of sense. Yeah, this body handler thing doesn't make a lot of sense to me. Okay, so this would work, except of course we don't have a place where we can submit them. But if I did a test, of course we'll get the typical. So this is from the first request. We get the Google custom page, of course, the status code. And also, I'm curious how this other request would fail, because first of all, that's an invalid URI, and let me just see how it would fail, and maybe see a bit of error handling there. I still need this body handler thing. Maybe I can do it in line. The response info, and yeah, I'm doing body handlers dot of string. What's the problem? Body publisher. Okay, body subscriber. Okay. This is body handler. I passed in a body handler. What is the problem? What the hell? Var body handler is supposed to use lambda. That has something I don't care about, and it returns HTTP response dot body handler of string. it's a lambda that accepts a response info and returns back body subscriber. Body handler from body subscriber. I mean, it's a lambda. I could store it in a variable. What am I missing? Can I do that? Body handler of string returns body handler. So it receives a response info and it returns back. Okay, let me see. Look at the send method, body handler, and body handler is a functional interface that receives a response info. Okay, returns back a body subscriber. So if we explicitly specify that this is a body subscriber, but that would make it okay. I'm using the body handler to get the body subscriber. And why is that? This is so weird. So this is a body handler that we get from calling body subscriber of string and passing the character encoding. And after calling this, we should get back a body subscriber and use that body subscriber here. So this body handler is a functional interface, which means I can pass it as a lambda. So I don't get why I can just store it in a variable and pass it in. So the last time we did it, we had body handler of a specific type, maybe the type information, the type signature. So that I've specified that, and so it receives a response info and gives us back a body handler. And in this case, we are also not using the response info for anything. So I don't get what's different this time. We'll compare them side by side. Okay, so this is a lambda that receives the response info. Okay, body handler. Okay, so that was a mistake. So when we call offstring, we get a body subscriber, but the lambda itself is a body handler, because we call send, you pass in a body handler, which is the functional interface with this function that receives response info and returns a body subscriber. So you don't pass in the actual body subscriber, you pass in a lambda that will return the actual body subscriber. So yeah, so this lambda is what we are storing. And yeah, so then when you call send, you pass in the request and the body sub, which is actually body handler. And of course you'll get a response here. And the response will have the body, and it will have status. Of course, I don't expect this to work because the endpoint, the URI is invalid. There's no such thing. So I'm just experimenting on like how you would actually write this. And let's see. So it looks like it fails silently. If your request is invalid, HTTP client will just quietly fail. Maybe that's because I did that. Let me see. Okay, now I have to. Okay. I'll not handle the Jackson error. JSON processing exception. I will not handle that. But I'll try and handle this IO exception that also has an interrupt exception. So the IO exception is on the client, which means we can use try with resources on the client itself. So we try bringing the client over, I'll create the client last minute and attempt to use try with resources on it. So that will give us the client, and it will make it auto-closable. So since it's IO, of course, we're supposed to close that. I don't know if we are supposed to. Okay, let's say if I was not using auto-closable, would I have a way of terminating the client? Oh yeah. So you can call close on the client, and so this will call. Also, it will check first if the connection is terminated, which returns false by default. So I guess this returns false by default, and it's not an abstract function. Return true if all operations are completed following a shutdown. Yeah, but they're just returning false. Implementation not on closing the HTTP client. Okay, so this expects some other API to implement it, but am I not using it directly? Why is it not already implemented? Because we're using HTTP client. Okay. Yeah. Wait. Okay. Does this override that close function? Okay. Wait, so who is responsible for overriding that close function? Because as it is, it just returns false. Doesn't seem to do anything. I mean, the check for whether it's the connection is terminated or not just returns false. It doesn't perform any checks. Okay, that's super strange. Maybe it's because I don't have a full picture of the inheritance hierarchy for HTTP client and the internal implementation. Maybe there is another class that, okay, yeah, it looks like HTTP client is an abstract class, and since it's an abstract class, there's okay, so there's likely a class that will implement HTTP client and override that is terminated function, which would probably just do some socket IO things to check whether the connection is still active. Okay, back to our code. So if you're not using auto-closable, you can call close of the client. So you can treat it like a socket. Internally, it will check whether the connection is still open. If it's not yet terminated, then it will call shutdown. And okay, shutdown is also a function that depends on the implementation. So some other internal library has to implement this. So it initiates an orderly shutdown in which requests previously submitted with send or send async are run to completion, but no new requests will be accepted. Okay, so you'll be closing the HTTP client. You won't be closing any existing HTTP requests on that client. So if there are still active HTTP requests on the client will not close until it's done. So it will not try to terminate any outgoing or incoming traffic. Instead, it will wait for any outgoing or incoming traffic to complete before it shuts down. But it will prevent addition of new requests on that specific client. So running a request to completion may involve running several operations in the background, like IO, sockets, and that, waiting for response to be delivered, which will all have to run to completion until the request is considered completed. So invocation has no additional effect for any shutdown. So yeah, so it's independent. It has method independence. This independent. So method independence is when is an operation that produces the same system state regardless of how many times it is executed. So it's a safe call. It's like a put. Is it put? No? Post. Or that depends also on the implementation of the server. But basically, if you call the method multiple times, it won't change the outcome. Because also considering its behavior, the fact that it doesn't interfere with any outgoing or incoming traffic, whether you call it a million times, what it will just do is prevent any new requests from being added to the client. But if there are any requests that are still being processed, those won't be interrupted. So that processing will still continue. So that is the shutdown part. So it will call shutdown, and then it will mark interrupted as false, and then it will enter this while loop. And inside this while loop, it will call await termination, which again depends on the implementation. And then, okay, if it's interrupted, then it will do some checks and then call shutdown now. and shutdown now just calls shutdown. So that's what that does. But since we're using autoclosable, you don't need to worry about that. I can just work with the client directly. And now that we have the client, we can call client.send and pass in the request and pass in the body handler. And here I can handle that error, that exception, IOEX, and the exception class, interrupted exception. So we can handle them together. Get exception, and yeah. So here I'll just print it. L to send, post request, and IOEX. Let's get the localized message. Okay, so I'm still not getting any communication back from HTTP client when I'm trying to hit an invalid URI. So it seems to be failing silently, which is not great news. It would be nice if we got a bit of a signal that this did go through. Let's check the response. Maybe it's wrapped in the response, that's why we are not getting any details. So the response, we can get the status and the body. Yes, no AI for now. I try to. There's some very special cases where it makes sense to use AI, especially when you're just researching these libraries, and that is when you've written a piece of code that you're sure works, but you are not sure how it will perform in an environment that you can't predict. So, for example, if you have a function that retrieves some data from a database table, the function works, but you're not sure that that is the most optimized version of that function. You feel like you can optimize it further. You could tell AI to rate your implementation, and what I've seen is, depending on the underlying database, you'll get some pointers, and this is not limited to databases. Basically, most LLMs, AI tools, will give you pointers on things you can improve in your implementation, and you can improve that and maybe test it out in production, or just have the confidence of, that's a nice optimization that I can use. But the original implementation ideally should come from you. The AI should be an assistant. Assistants don't come up with the original piece of work. The original piece of work should be coming from you. So that is my attitude towards AI. It's a nice assistant. It can look over the document, ensure that I signed everything correctly. It can deliver the document to the client, but I'll not have it draft the contract. Yeah. Because if it hallucinates and drafts the wrong contract, and now you go to jail, it would be difficult to tell the judge it was AI. I'm not the one responsible for that. The AI is the one that drafted the contract. It's still your responsibility. But they're good for checking your work. If you've written a piece of code and you're not very sure that it doesn't contain any unexpected bugs or some performance hit, give it to AI. The AI will be able to pick up those patterns very quickly. And if you have like logical errors, the AI can pick up a lot of that. But in terms of writing good code, that's still on you. I feel like human beings are much better at writing readable code because they have to read it as they write it. But the AI is very sure about what it's doing, even when it's hallucinating. So that confidence puts it in a situation where it doesn't need to validate its work. But you are forced to validate your work because you have to reason about it as you like create the work. So I use AI just not for writing code. Validating code, yes, not writing it. So here we can get the status and the body, and maybe that will tell us what is happening. I don't know if there's anything else we can get from that, from the response. We can check the SSL session. It's not necessary for this context. Connection label. What does this connection label have? Okay, just curious. Let's see what this connection label is. Maybe here I could use the lambda if present. If present or else, which expects a consumer. So the consumer, it's a functional interface that accepts a value but doesn't return anything. So here we'll have a lambda that accepts the value and just consumes the value. So the way we'll consume it is we'll call IO println. Just print like that, and we should put io.println and then we pass in the value. Expected two arguments. Which other argument? Okay, so the consumer and runnable. Okay, then we can just use if present, which just accepts the consumer. And on the printout, maybe I could specify that this is something I don't know, connection label. And let's print out the status, which is this is HTTP status, and let's print out the body. Okay. So Eric is saying, for someone exploring backend for the first time from front-end background, what's your take on the best backend tech to get into right now? Our priority being job security. Oof, that's a tough one, especially when you bring up the job security part. If it's in the Java ecosystem, Spring Boot will get you hired. So I'd go with Spring Boot. But to be a very excellent Spring Boot developer, you need to know Spring Framework because, like I said, Spring Boot is sort of a wrapper around Spring Framework's APIs. The main advantage that Spring Boot brings is just avoidance of configuration. In fact, the tagline is convention over configuration. But if you know how to do the configuration, when it gets to a point where you have to really customize things on the back end, you end up being able to do a really good job if you understand Spring Framework. And if anything goes wrong when you're working with Spring Boot, you can contextualize the problem because you can see underneath Spring Boot, you can see into Spring Framework, and if you can go beyond Spring Framework and understand Jakarta and understand the specification behind some of the things you're using, like JPS specification, the servlet specification, JAX-RS, and all the other specs that surround Jakarta, then when things fail at the high level layer, which is Spring Boot, you can understand those issues much easier if you know how Spring Framework behaves, and if that is not enough, you can contextualize those failures easily when you understand Jakarta and the specifications that surround things like Hibernate, and like I said, servlets and stuff like that. And if you can go further and understand sockets and the underlying things, I think you'd be at a much better position. Otherwise, if you just know Spring Boot and a failure happens, you get frozen. Like you'd not know what to do next, other than to Google and try and find the problem, or to become a vibe coder and use an LLM to fix your problems. But I would try to understand all the layers because they depend on each other. Unlike something like JavaScript, within the Java ecosystem, the frameworks rely on each other. They form like a building. There's like a basement, there's a first floor, second floor, third floor. So the frameworks in Java work like that. They're like what do we call these things? Lego bricks. In that you attach one, it connects to the other, and that chain is what forms the whole ecosystem. Jakarta Spring Boot depends on Spring Framework. Spring Framework depends on Jakarta Jakarta depends on the Jakarta list of specifications, and the Jakarta specifications depend on other things underneath, like sockets and application containers like Tomcat. So if you understand the whole top to bottom layering of the frameworks that are within Java, then you'll be at a good position. When it comes to like job security, I think it's a tricky subject because I think job security also depends on office politics. So it's not so much your technical ability, it's also some human skills, which as developers we don't like to focus on, but that's the reality. So you might be really good, but job security could still get tricky because of, well, you need to navigate office politics, which even I don't know how to navigate office politics. So I can't advise you on that. But when it comes to technical ability, that is what I think you should know. Understand the language fairly well, understand Jakarta, Spring Boot, Spring Framework, because they all depend on each other. They're not exclusive. So ideally, you should have a clear understanding of all those layers that form the Java ecosystem. There's no duplication of work in Java, which is very nice. You'll hardly find a framework doing a thing that another framework is already doing. So that's why I'm still using Jackson. So if this was JavaScript, there would be like a million Jackson libraries. So, but in Java, we have one Jackson and some wrappers built around Jackson. You won't find like duplicated servlets implementation. You'll have the Jakarta implementation of the servlet spec, Spring Framework forming wrappers around that servlet spec, and Spring Boot forming even more convenient wrappers around that servlet spec. And of course, Tomcat implementing the container that's able to run those servlets. So there's no duplication of work. Also, it's advantageous and a worthy use of time to explore all of those layers. Okay, so I'm seeing the response here is 404, and I'm getting an HTML document. Since I was querying a server that doesn't exist, maybe company.com exists. Let me see. Company.com. Oh yeah. Okay, so somebody actually owns company.com. So this is what we were hitting, and I think we are getting that document. Let me see if I can find company.com. There's some CSS, really nice CSS here. And okay, this guy has CSS at the bottom of the page, not at the top. That's interesting. And okay, so this page does not exist. Okay. Yeah, so we are trying to do a post on an endpoint that doesn't exist on there. So, I don't know if they support options. Okay, 90% chance it's not supported, but okay, just out of curiosity, let me try doing options on that endpoint. So I'll need a request. Call this request 3. Okay, for my HTTP request, HTTP request, get a builder, and we are hitting https://www.company.com. Oh yeah, to create this URI for using it. Could also just create it once and use it again, or run it everywhere. Right, that. And oh yeah, just use the builder. Okay, so it's not even a supported method. So options allows you to scan available endpoints if the owner of the server supports it. It's like a way it's like HTTP native version of HETIAS, Hypermedia's the engine of application set. But most servers don't have that implementation, so I won't even waste my efforts. But anyway, you can see that I guess what I've learned here is if there's a failure with the request, I should not expect exceptions to occur. Instead, I need to query the response itself. So Java won't swoop in and pick up things like getting a 404 from the server or something like that. That will just be nicely wrapped in the response itself. And to handle any failures on the request, you have to reach in into the response, extract the status, extract the response body, and actually do some processing with that. So it's the language itself won't there's no panic button if for instance I'm querying a request URI that doesn't exist. Okay, let me see if there's anything else here. So we've seen timeout, headers, and a body publisher for post requests. Or you can reference a file in the system and it will extract the JSON. Okay. So we were doing synchronous with send. Of course, there's send async for asynchronous calls. actually it's a really nice API. So instead of waiting for the response or extracting it to a variable, you can just chain the calls. So here we'll do, instead of calling send, this would be send async, and instead of having the response, instead would use then apply, and we have a lambda. What kind of lambda? Oh, it's a function. So this accepts a function lambda. Yeah. So receives a value, receives a value, and then does some processing and returns a value back, a different type. And I wonder what this would receive. Okay, so the actual response. And we can do something with the response. For example, we could do this. Yeah, so we can do that with the response, and we can do everything we're doing with the response here, except this is async, so we don't have to wait for the actual response from the server to be available before we plan out the course of action. So then apply will use a completable future. Actually chains multiple completable futures. So I think at some point you'll call a join, or it probably does that internally. Then apply. Okay, maybe then accept is the equivalent of join here. So is then accept, and this will call in accept stage, and take the cons. Okay, so the executor. Oh yeah, so this calls accept, and okay, so that's a different lambda. Okay, so I'm looking for stuff that's related to the completable future, and specifically at which point do we join multiple completable futures on this chain call, and wait for the final response. Okay, so we call then apply, and then we can call then accept. But what does then accept do? So this receives a consumer, and this consumer will be, I think it will be consuming the response body. This is still the response. Just be sure. No, it's just an object. Okay, if it's an object, then it's an object of what? Accept. Body handler is handling string, which means our response body should be a string. So when we call then accept, what are we doing? Double future then accept. So sometimes within Java, you find that some things don't have documentation, like this classic example. So you kind of have to go out and seek the example, the samples, of course, and seek out documentation. And if you're lucky, you might find some documentation. So this is it. Yeah, there it is. Then accept. So then accept returns a new completion stage. That when this stage completes normally is executed with these stages resolved as the argument to the supplied action. Okay, so this is like the end to the conclusion to the completable future chain. An action to perform before completing the returned completion stage. Okay. And when it's dealing with the consumer, I guess that depends with the value that was returned on the previous then apply call, which we can still try and understand by just printing out that and see whether it's the response or whether it's something else. Okay. Yeah, in fact, that depends on what we return here. So we could choose to return the body, and that will form the next chain, which is this call to then accept. And now we don't need this additional exception handling. Don't need this because we're not using send, we're using send async. And let's see how that works out. Okay, so it still does the same request. We get a 404 because that spot doesn't exist on that server, and we get the HTML, and just prefix this. Might point me to, so the body is the HTML itself. So if I prefix it, perhaps it will be a signal that's printed twice here, and then once we call then accept, this value is passed down to that lambda, and we print it a second time. Yeah, so that's what's happening. So we get the response body first. So this is the first time we get it. Yeah. And then when we call, so we return it from then apply, and when we call then accept, it will pick up that value, and that will be used for the printout. Let's use something different like the status code. Yeah, so if we use the status code, we'll see that we get a 404 here. So this is how you can chain calls with completable feature. Interesting. So that is then accept. So data as reactive streams. The request and response bodies are exposed as reactive streams, asynchronous streams of data with non-blocking back pressure. The HTTP client is effectively a subscriber of request body and a publisher of response body bytes. Okay. The body handler interface allows inspection of the response code and headers before the actual response body is received, and is responsible for creating the response body subscriber. Okay, so I guess that this is now entering the dark side, which is reactive programming. So you get this concept of flow and flux. So you get flow, and you get a publisher. This is definitely reactive programming. And let's see an example. So there are adapters between flow and pub/sub types of the HTTP client. So we're working with HTTP2, client support 1, 2, and 3 by default. So I'll not go into reactive programming. I've never been a fan. I find it extremely complex, and I guess for my use cases it's a bit unnecessary. But I'm sure there are people that find it indispensable. Not me. Therefore, I can save myself from the complexity of doing reactive programming. So the Java HTTP client supports 1.1 and HTTP2 and HTTP3. So this is good. Since JDK 26, by default, the client will send requests using HTTP2. I can almost guarantee that will still be 1.1, and then the reverse proxy on the server is will be responsible for converting to HTTP2, and that will also depend with whether the actual backend systems support HTTP2. Requests sent to servers that do not yet support HTTP2 will automatically be downgraded to 1. Okay. Here is a summary of major improvements that to brings header compression, single connection to the server, multiplexing, server push, and binary format, which is more compact. So there's also support for HTTP3, specified in JEP 5.17, added HTTP3 support to the HTTP client API in Java 26. Reasons explained in the JEP. So this is the JEP responsible. The status is closed and delivered in Java 26. So this is the JEP that added support for HTTP3. I think the main thing is multiplexing. When it comes to 3, and I think the binary format thing is probably also limited to 3. Yeah. Let me see the RFC for could be wrong. Features. Okay, 3 overview. So HTTP3 provides a transport for HTTP semantics using the quick transport protocol and an internal framing layer similar to HTTP2. Once a client knows that a HTTP3 server exists, at a certain endpoint, it opens a quick connection. Quick provides protocol negotiation, stream-based multiplexing, and flow control. Discovery of HTTP3 endpoint is described in 3.1. So I think the main thing with 3 is this quick underlying protocol, which if write just helps the client and the server negotiate how they're going to do multiplexing. Yeah, UDP-based multiplexed and secure transport. Let's see the overview. Sending and receiving data. So stream frames encapsulated data sent by an application. An endpoint uses the stream ID and offset fields in stream frames to place data in order. Endpoint must be able to deliver stream data to an application as an order byte stream. Okay, I guess that refers to the binary data that's hinted at here. Why did I see that? Okay, so yeah, quick, we just saw that in the RFC, or the spec for HTTP3. So so you will specify the version the same way we did here. What was that? So you specified on the client, I believe, yeah. So if you wanted to use 3, I can't specify that because of, I mean, I can't use 3 because of my current predicament. I'm still on Java 25. So from the spec, this was added in Java 26, so I still can't use it. So right now I can use HTTP2, I can use 1.1, but not 3. But the code would remain mostly the same. The only different thing that you would end up doing is the protocol version specification. So you specify a different protocol version. But I think at the application layer, you'd still write the same code that we are doing. The binary data conversion and the multiplexing would happen internally. I think internally HTTP client would handle the details of how all that works. As a developer, you probably just end up writing the same sort of code, maybe using completable feature to take advantage of the asynchronous request processing, but it would remain largely the same. Okay, so I guess I've looked at that whole document, and I've looked at the JEPs as far as they could point me towards anything. The details are a bit limited on the JEPs themselves, but that guide was super helpful. This one. The guide I was using, yeah, that was helpful. But the specifications don't talk a lot about the practical usage, which I guess is to be expected. So that's what I wanted to explore on this stream. Essentially, I want to look at some of the JEPs surrounding file I/O and network I/O. Networking. Okay, maybe the right word is networking. So JEPs related to networking and file I/O. Essentially preparing for some sessions that will have that I apparently have the responsibility of handling within KejaJag. That is based on the file I/O. So the next stream, I'll try looking at the stuff that I thought I would be looking at on this stream, which is the new IO APIs, that is files, paths, and the whole family. Yeah, so there's this paths API, there's a files API. I've been using them, but not with some deep understanding of the underlying implementation and specification of how far you could push them. But I've been using them here and there, my God. But I wanted to do a deep dive before I am given the responsibility of introducing people to using them. And maybe I can have a more structured way of looking at the old IO APIs, buffered writer, file reader, and the others, and the new APIs, that's files, paths, and the rest of the family. Those will kind of see what the relationship is between them. But I got sidetracked a bit, which was a good sidetrack, and I ended up looking at HTTP client on the stream. So on the next one, I'll try and look at file IO, maybe do some processing there. So I guess that's it. I'll catch you guys on the next one.